Welcome to the channel. We're super excited to share some awesome stuff with you. Today's video about Beyond Time, the ultimate journey through space, galaxies, and the unknown. In this video, we'll be looking at some questions about the universe that science cannot answer yet. Join us as we look at more mind-blowing space facts that will blow your mind. Make sure to watch until the end for an extra special treat. The observable universe is expanding at an accelerating rate. Light from distant galaxies is red-shifted, indicating that they are moving away from us. This discovery in the 1920s by Edwin Hubble led to the realization that our universe is not static but expanding, a revelation that earned him the 1935 Nobel Prize in Physics. Today we know that the expansion rate, known as the Hubble constant, is around 70 kilometers per second per megaparsec. However, scientists have observed that distant supernovae appear dimmer than expected, suggesting that the expansion rate might be increasing. This acceleration could be attributed to a hypothetical substance called dark energy, which makes up around 68% of the universe's total energy density. But how big is the universe? The diameter of the Milky Way is about 100,000 light-years across and contains an estimated 100 billion stars. Other spiral galaxies are similar in structure, though they vary in size. For example, the Andromeda galaxy is larger than the Milky Way with a diameter of around 220,000 light-years and an estimated 1 trillion stars. The universe is filled with billions upon billions of galaxies, each containing countless stars. Our solar system is just one tiny part of this vast expanse. Scientists estimate that the observable universe extends for around 94 billion light-years in all directions. Beyond this distance, the universe becomes opaque due to the limited range of our current technology. However, the actual size of the universe might be infinite. At the center of most galaxies lies a supermassive black hole, a region of space-time where gravity is so strong that nothing, not even light, can escape its grasp. Black holes form when massive stars collapse, and their cores collapse under extreme gravitational forces. Their size is measured in terms of mass, not radius or diameter, with the boundary of the black hole being defined by the event horizon. Anything that crosses this boundary is pulled into the singularity at the center where matter is crushed to infinite density. To visualize the immense gravity of a black hole, consider the following. If you were to place a 1 kilo mass on the surface of the Earth, it would experience a gravitational force of approximately 10 newtons. Now imagine placing that same 1 kilo mass on the surface of a black hole with a mass of 1 million times that of the Sun. The gravitational force on that mass would be thousands of times greater than the Earth's gravity. At the event horizon of this black hole, the gravitational force would be about 100 billion times stronger than Earth's gravity. And as you approach the singularity, the gravitational pull becomes even more extreme, reaching trillions of times Earth's gravity before finally crushing the object into a pancake-like shape. Most astrophysicists believe that every galaxy in the observable universe has a supermassive black hole at its core, including our own Milky Way with its supermassive black hole known as Sagittarius, a star. Black holes play a crucial role in the evolution of galaxies, influencing their structure and dynamics. They can also be detected through their gravitational effects on nearby matter such as stars and gas. Additionally, black holes emit a faint glow known as Hawking radiation due to quantum effects near the event horizon. While these phenomena provide clues about the nature of black holes, many aspects of their behavior remain mysterious and actively researched areas of investigation. Black holes continue to captivate scientists and space enthusiasts alike as we strive to understand these enigmatic objects that hold the key to unlocking the secrets of the universe. Multiverse theories propose the existence of multiple universes beyond our own, which together comprise everything that exists, including space, time, matter, and energy. These theories suggest that our universe is just one of many, potentially infinite parallel realities that exist simultaneously. One of the most widely accepted multiverse theories is the many worlds interpretation of quantum mechanics. This interpretation posits that every time a quantum event occurs, such as the decay of an atom, the universe splits into multiple branches, each representing a different outcome. Over time, these splittings lead to a vast network of parallel universes where every possible outcome of every quantum event has been realized. Other multiverse theories include the inflationary multiverse, which arises from the idea that our universe is just one of many that were created during a period of rapid expansion known as inflation. Each bubble of inflated space represents a separate universe with its own physical laws and constants. The eternal inflation model further suggests that new universes continue to be created even today, leading to a constantly expanding multiverse. String theory and M-theory also support the concept of a multiverse, proposing the existence of additional spatial dimensions that are inaccessible to us. These dimensions could harbor other universes with different physical properties. However, the idea of a multiverse remains highly speculative and controversial. Currently, there is no direct evidence to support any multiverse theory, and they face significant challenges in terms of falsifiability and scientific consensus. Despite these challenges, the concept of a multiverse continues to fascinate scientists and the general public alike, as it raises profound questions about the nature of reality and the possibility of other universes coexisting alongside our own. Science has made remarkable progress in understanding the complexities of the universe, but there are still many things that remain unexplained and beyond our current comprehension. There are several instances where science meets its limits and veers into the realm of mystery. For example, one such area is in the study of consciousness. Science can explain the biological mechanisms of the brain and nervous system, but it struggles to explain the subjective experience of consciousness. How do physical processes give rise to things like qualia, the redness of red, for instance, or the painfulness of pain? Science also faces challenges in explaining the origin and nature of life. It can investigate the chemical processes involved in metabolism and reproduction, but it cannot explain how non-living matter gave rise to the first living organisms. Similarly, science can describe the evolution of species over time, but it cannot explain the emergence of consciousness or the meaning of life. Another area where science meets its limits is in understanding the human psyche. Science can study the brain and nervous system, but it struggles to fully comprehend the complexity of human emotions, motivations, and behaviors. Human relationships, morality, and the search for meaning are also difficult to explain using purely scientific methods. Additionally, science has limits in explaining certain paranormal phenomena. While science can investigate and test for things like telekinesis or clairvoyance, it cannot currently provide a scientific explanation for these phenomena. Similarly, science cannot explain religious experiences or the existence of a higher power. Overall, there are many things that science does not and may never be able to explain. There are inherent limitations to the scientific method, and there are some mysteries of the universe that may always remain unsolved. However, science continues to advance, and what was once considered impossible to explain using science may eventually be understood. The unknown and unexplained should not be feared, but rather embraced as an opportunity to expand our understanding of the world around us. By continuing to explore the mysteries of the universe, we can gain a deeper appreciation for the complexity and wonder of existence. This brings us to the end of our video. We hope you enjoyed learning about these amazing space facts. Don't forget to share your thoughts and comments below. Thanks for watching. If you liked this video, please hit the like button and subscribe to our channel for more videos like this.